Alright, this lesson is on scatter plots, informal assessment using a line of best fit. In the last lesson, we learned about patterns that scatter plots can take. This is an indication of a strong positive correlation. Positive because it's going up. It looks like the change as x gets increased, y is also increasing. This is a weak positive correlation. Why? Because the points are, as you can see, a little more spread out, where in the first example they're more clustered. In this example, we see that this is a strong negative correlation. It's going in the down direction. As x increases, y is decreasing. And in this example here, we also see a negative correlation, but it's a little weaker. The points are not as clustered around any particular line. And in the last example here, we see that there is no correlation. There does not seem to be any relationship between what is happening with x and what is happening with y. Points are kind of all over the place, up and down. So now we're going to look at the pattern, and we're going to look at it in terms of what we're going to call a line of best fit. The pattern of this scatter plot appears to be a positive linear relationship. Linear because it appears to fall, the points appear to fall up upon a line or in a line direction. And it's positive because as x is increasing, y is also increasing. In order to analyze this relationship further, we'll informally draw a line of best fit. If you used a calculator, one of those TI calculators, you could draw an exact line of best fit. And in the same light, if you were to take the average or the mean of all of these data points and then plot that point, the mean, and draw a line directly through it, your line of best fit would be more accurate as well. But for these examples and for this lesson, we're just going to be looking at an informal line. So what we have here is a line of best fit. That would be the blue line that we have drawn. So based on the line that we drew, by definition, the line of best fit is a straight line that comes closest to the points on the scatter plot and that best represents the data overall. Note that sometimes the line may not pass directly through any of the data points, but we will see that there are about the same number of points above and below the line. We have 1, 2, 3, 4, 5. We're going to consider this one an outlier. So we have 1, 2, 3, 4, 5, 6. That's pretty darn close, and our points are really hugging that line. So it's a pretty good line of best fit for this set of data. Here's some basic tips for informally drawing a line of best fit. You're going to look at the data points and determine the direction, whether it's going in a positive or a negative direction. So that would be the slope. You're going to draw a line in the middle of the data based on the overall slope. Then you're going to assess that there are approximately an equal number of points on both sides of the line of best fit. You're going to adjust your line as needed. Also assess the distance the points are from the line of best fit, adjusting the line as needed such that the points lie at approximately an equal distance from the line. So what does that line of best fit tell us? Well, in this case, most of the data points are very close to our line, and this is an indicator of a strong correlation between the two sets presented. A line of best fit on a scatter plot can also be used to make predictions. So let's make a prediction. Suppose the y-axis represented fertilizer, the amount of fertilizer applied to a particular type of plant. And along the x-axis, that represents the height of a tomato plant in centimeters. So if that's true, then it does appear that as we increase the amount of fertilizer that we're applying, that it is significantly affecting the growth of the plant. So we could predict that if we applied, let's call it right here, so 3.75 milliliters of fertilizer, if we went along that line, then if we just extended our line of best fit, we'd have a point approximately here, and we could predict that our plant would be approximately 15 centimeters. Now, does that mean the plant is definitely going to be 15 centimeters? No, because remember, our best line of fit, this is just an approximation. It's our best estimate, but it's going to be close. Let's try this one. The overall slope or direction is downward. That's negative. If I draw the line of best fit here where you see, I can see that there are more points above the line than there are below it. But if I move the line and adjust it slightly, this is a little bit better. We have a couple of outliers, but overall, this line is a better fit for the data. It represents the data better. Now let's look at these. Where would I draw my line of best fit? Well, on the first one, we see it is a negative slope. And I draw my line here. Our line is the best estimate of best fit, noting that our points are approximately an equal distance from our line. And on the right side, we see this is a positive slope. Our line of best fit is our best estimate. It's not necessary that it passes directly through any particular data point, but that it best represents our data. So as you can see here, we're pretty darn close to assuring that our points are an equal distance approximately from the line. Now this line could possibly be moved a little bit down, so we can angle it maybe a little better. In this from here, we could possibly angle it a little better this way. But again, it's just an estimate. It's our best guess for a best fit. Is there a line of best fit for this scatter plot? Look at the data and see what you think. Well, as you see the data along the x-axis changing, is that significantly changing the data along the y-axis in any particular pattern? Well, there really isn't any relationship between the data points in the scatter plot. The change in one data set is not affecting the other data set in any specific pattern. And since there is no correlation, we cannot estimate a reasonable line of best fit that would be representative of this data. Okay, well that ends this brief introduction to the scatter plot and the line of best fit. So enjoy the activity and give it your best try.